Composite materials. Composite materials are similar to alloys in that different materials are put together to create a new material with added properties. Alloys are melted and mixed when being produced, whereas composite materials are bonded together with either adhesives or resins. They can also be bonded during the manufacturing process. Carbon fibers are usually combined with other materials to form composite. For example, they are mixed with a plastic resin and baked to form carbon fiber, which has a very high strength to weight ratio and is extremely rigid, but can be brittle. Here are some examples of composite materials, what they are made from, what properties they have, and what products they can be used for. Carbon fiber composites. What's it made from? Carbon fiber sheets, resin, which is also called epoxy resin. Carbon fiber composites have an excellent strength to weight ratio, are very stiff and rigid, and are also corrosion resistant. They can also be molded into many complicated shapes. Carbon fiber is used in products such as racing car parts, bodywork, seat, as well as high-end bicycles and sport equipment such as tennis rackets, due to its rigidity, strength and lightness. Glass reinforced plastic, or GRP. This is glass fiber sheets mixed with resin, once again epoxy resin. GRP is lightweight yet strong and rigid. It is also a good electrical insulator, moldable into many shapes, low cost and corrosion resistant. Due to its relative strength, rigidity and corrosion resistance, GRP can be used for water park slides, roofing and electrical enclosures often seen on the side of roads. Kevlar composites. Kevlar fibers, sheets, resin, epoxy resin. Kevlar composites can be very stiff and rigid, as well as being very lightweight. They also have high heat resistance and high impact resistance. Due to its strength to weight ratio, Kevlar composites can be used for sports equipment such as rackets, cricket bats and bicycles. It is also used for protective clothing, ballistic vests, and other pieces of armor such as helmets due to its rigidity and stiffness. Engineered timber. It's a mix of timber, woods and adhesives. Engineered timber has a good strength to weight ratio and can be stiff compared to traditional timber. It is also a low cost and durable. Engineered timber can be used in many applications: flooring, furniture and building materials such as interior walls and joists. Reinforced concrete. So this is made out of cement, sand, aggregates, which is gravel, steel reinforced bars. Reinforced concrete has excellent compressive strength. It's very durable and corrosion resistant. It is also moldable, fire resistant and low cost. Due to its compressive strength, fire resistance and low cost, reinforced concrete is used extensively in the building industry for structural support in large buildings and bridges. Plastics. Most common plastics are known as polymers, are made from the chemicals naphtha, extracted from crude oil, see raw materials page 5, in a process known as polymerization. Polymerization turns monomers, in Greek mono, one, meros, part, into polymers, in Greek poly, many. Polymers are monomers joined together to create chains, polymers, plastics. So a monomer is a type of molecule that has the ability to chemically bond with other molecules in a long chain. So there we see monomers becoming polymers. Plastics are used extensively throughout the world as they are incredibly versatile. They can perform many tasks, they can be produced at a very low cost, and they have some amazing properties that natural materials such as metals and timbers do not have. What is so effective about plastic, and why do so many engineers and designers want to use it in the products and solutions they develop? With plastic, you can do the following: mold it into any shape you can imagine. Use it outside as it will never rust. Make it any color you want. You can even make it transparent. Apply many types of finish such as textured or glossy without having to go through another process. Create strong and lightweight products. Make products that are safe for kids and pets. Keep everything at a low cost, and it's also easy 3D print into any shape. Even though most plastics come from refining crude oil and are relatively difficult to recycle, you can see how, as a material, it can create many solutions for engineers when working on projects. It would therefore be an easy choice of material with so many potential applications. Here is a list of common properties shared by most plastics. So it has good strength to weight ratio, moldable, self-finishing, corrosion resistance, ductile, good electrical insulator, low cost, chemically inert, so good for children and pets, durable, and good impact resistance. Common plastics are generally split into two categories, which is thermoforming or thermoplastics and thermosetting plastics. Thermoforming plastics. Thermoforming plastics are able to be molded into shapes, reheated, and remolded into a different shape if needed. Thermoforming plastics are also recyclable, making them a relatively good material option for the environment. The stock forms for thermoforming plastics tend to be sheets, pellets, and granules. Underneath here, we can see the polymer chains within thermoforming plastics, and you can see that there are no links between the chains. Here are some examples of the types of thermoforming plastics that are available, what properties they have, and where they can be used. So acrylic. Acrylic has good strength and stiffness but can be brittle. Good optical clarity, easy to see through and easy to fabricate shape and make things from. Acrylic has a vast range of uses including clothing, if it's made into thread, paint, signage and furniture. Nylon. Nylon has very low friction capabilities, very good tensile strength and abrasion resistance. Due to its low friction properties, nylon is commonly used for gears, cogs, clips, ropes and runners. It can also be formed into thread for clothing and luggage. High impact polystyrene or HIPS. HIPS is a common plastic due to its very low cost and how easy it is to fabricate. HIPS can be used for applications such as food packaging, yogurt cartons, signage and storage containers. ABS. ABS is tough and has great impact resistance and also has good heat resistance. ABS is used for products such as safety helmets, computer keyboards and Lego bricks due to its toughness and impact resistance. Polyethylene. Polyethylene has a low melting point and is very ductile. Due to its ductility and low melting point, polyethylene can be stretched thin without failing. This makes it great for products such as drink bottles and liquid containers. Polypropylene. Polypropylene has good heat resistance, is tough, and has good chemical resistance. Polypropylene can be used for garden furniture, bottle tops, and storage crates. Polycarbonate. Polycarbonate is a very tough plastic that has relatively good abrasion resistance and good optical clarity. Polycarbonate is very tough and therefore it is very good for products such as car headlight covers, glass replacements, so things such as bus shelters and safety goggles. Thermosetting plastics. Thermosetting plastics cannot be reformed once they have been heated and set. They are more difficult to recycle than thermoforming plastics and tend to be less flexible and more brittle, but not always, due to the way they are constructed. The stock form for thermosetting plastics tend to be powder. So here we see the polymer chains within thermosetting plastics, very similar to the thermoforming plastics, however they are linked together through strong covalent bonds. Here are some examples of the types of thermosetting plastics that are available, what properties they have and where they can be used. Thermosetting plastic name. Urea formaldehyde. Excellent electrical insulation properties. It is relatively hard and has good heat resistance. Where can it be used? Well, it's used within electrical sockets and plugs and toilet seats. Epoxy resin. Epoxy resin is low cost, has excellent adhesive properties, is hard, is a good electrical insulator and is moldable. Used in many applications, from adhesives to being combined with other materials such as carbon and glass fiber to create strong, light and rigid products such as car parts, GRP roofing. Melamine formaldehyde. A very tough but light material can be molded into most forms. It also has good electrical and heat resistance. Can be used on laminate flooring as well as kitchen products such as childproof plates and cutlery.